Tonight's video is about factors that affect chemical reaction rates, and this is our first video in our unit on battery power. My objectives for you tonight are that you can identify the factors that affect chemical reaction rates, and that you can explain how the factor affects chemical reaction rates. There are four factors that can affect chemical reaction rates. The first of them is concentration. And what concentration is how much solute is dissolved in the solvent. This is also known as moles per liter. The higher the concentration, the higher chance for a chemical reaction to take place. And the reason is that in order to have a chemical reaction, you need to have a collision between the molecules you want to react. So if I have, for example, if I have copper sulfate, which we saw last week, and I want to react it with iron metal. In order for that to happen, our molecule of copper sulfate here has to collide with iron here for a reaction to take place. And so once that reaction takes place, then we have that should be a 2. Fe2SO4 taken 3 times, and we have copper that's free. If you don't have any collisions, though, you will not have a chemical reaction take place. This goes back to what I was talking about before, in that your stomach is able to handle low concentrations of hydrochloric acid, and we're talking 0.001 moles per liter. Whereas if you take something like an 18 moles per liter concentration of hydrochloric acid, this would be a lot more damaging to your body because there's more collisions between the hydrochloric acid and the cells within your body. The second factor that can affect chemical reaction rates is temperature. Now, temperature controls the kinetic energy of molecules in a solution. So the higher the temperature, the more kinetic energy. The lower the temperature, the less kinetic energy molecules have. And what kinetic energy does, if you're at a higher temperature, this increases the kinetic energy, which increases the rate of collisions and the force behind those collisions between molecules. So a liquid with dissolved salt at a high temperature is going to react faster than a liquid that's at a low temperature with salt dissolved in it. The third factor that affects reaction rates is surface area. And this is a term from your geometry class here. And one way to look at it is if I have a pill that I've taken, the only way for that pill to get into your system and to work is that it has to react with its receptors. And for that to happen, the pill has to come in contact. And the only way that a pill can come in contact with its receptors or begin to digest is from the surface. If you were to crush that pill so that it was in lots of smaller pieces, okay, there's more surface area, and the more surface area here, the more reactions that are going to take place in a given period of time. Okay. My last reaction rate factor that we're going to talk about here tonight is that of a catalyst. And what a catalyst is, this is generally a chemical or some form of matter that's added to a chemical reaction, but it's not consumed during the reaction. And what this does is it speeds up the reaction rate. In biology, you'll hear this also called an enzyme, and we'll talk a little bit more about catalysts as enzymes a little bit later this year. But an example of this is the addition of manganese dioxide to hydrogen peroxide. And what it does is it just helps orient the chemicals in a way so that they can react. Because for a reaction to take place, you have to have collisions between the chemicals you want to react, your reagents, and it has to have collisions in the right way. If that doesn't happen, you're not going to get a chemical reaction. For our lab on Monday, what's going to happen is you're going to come in, you're going to work with your group, and there's going to be 4 different reaction rate stations at your bench that you're going to look at. And so you're going to look and see how exactly in real life do these reaction rate factors affect the rate of reaction. And so watch the video, take notes, and we'll go over this on Monday.